everyone. Today the experiment name is design RC phase shift oscillator using opamp. So first of all we draw the circuit diagram. Okay, this is the circuit diagram. You must be careful about these two connections. The pin number 4 for minus 12 volt and pin number 7 for plus 12 volt. If you connect this inversely, that is plus 12 volt go to pin number 4 and minus 12 volt go to pin number 7, the IC will be burned immediately. We get the output from pin number 6. Now I describe the circuit. First of all, this 3R value, this is R1, R2 and R3. R1, R2, R3. This three value of resistors will be same, that is 1 kilo ohm. Next we go to the capacitor. This is C1, C2, C3. The value of C1, C2 and C3 must be same, and we take 0.01 microfarad. In market it is called 103. This capacitor has no polarity, and there is a feedback resistor, we call it RB. The value of RB equals to 100 kilo ohm. So now I describe the circuit one by one. First, this R1 connect to the pin number 2 of the opamp. Next, 3 will be grounded. The another portion of the R1 connected to the C1. As it is non-polarized capacitor, you can connect any pin. The another part of the C1 connect to the C2, and where it is joined, there is a resistor which is R2 that is grounded. Next, same C2 and C3 connected, and the join of the C2 and C3, there is another resistor that is R3 which also grounded. There is another resistor that is RB. We take this resistor, that the value of the resistor is 100 kilo ohm, and we get the output from the pin number 6, that is a sinusoidal signal. How we get it? This RC circuit. From this RC circuit, every RC circuit we get 60-degree phase shift. So as there is 3 RC circuit, so we get 3 into 60, that is 180-degree phase shift sinusoidal signal. Now we go for the calculation. So as we know, first of all there is an observation table. we have to measure the frequency and amplitude of the output. Amplitude, then time. If we divide 1 by t, then we get the frequency. These three readings we have to measure from the output signal. Then there is another equation that as per theoretical, that is F equals to 1 by 2 pi RC into root 6. So it is the value for R, that is R1 or R2 or R3. So as I calculate the R by the multimeter, I get the value of R, that is 0.98 kilo ohm. So if we put the value, that will be 2 into 3.14, and it will be 0.98, that means 0.98 into 10 to the power 3 ohm, into the value of R, that is 0.98 into 10 to the power 3, and the value of C, this one, 0.01, the value of C equals to 0.01 microfarad, that is 0.01 into 10 to the power minus 6 farad. So 0.01 into 10 to the power minus 6. It is hertz. So if we calculate this equation, we get the value of the F, that is 5.32 kilohertz. You can do the calculation. Now we go to the, this is theoretical part, theoretical. And from practical, that we measure from the CRO, then we get the value of T from the CRO. This is total T, and if we divide the T, then we get the value of frequency. Now we can compare these two values, that is theoretical and another is practical. Now I want to introduce the discrete component which we use in this circuit. First you can see opamp. This is opamp 741. You have to keep the notch in your left side, and below the notch, that is here, you can't count anti-clockwise, that is 1, 2, 3, 4, 5, 6, 7, 8. So from pin number 6 we get the output, and 3 for ground as per circuit. So this is 741, that is opamp. Next we go for the resistor. The value of resistor, that is 1K. How we calculate the value from the color code? 1K, 1 kilo ohm, that means 1000 ohm. We know the first band, 1 means brown. The second band is 0 already, so this is black. And this is 20, that is 10 to the power 2. The 2 means we know it is red. So 1K, 1 kilo ohm resistor, the color code will be brown, black, red. You can see. This is brown, black, red, and fourth band for tolerance. For the tolerance, we get the value 0.98 kilo ohm, not 1 kilo ohm. So it is 1 kilo ohm resistor. Next, we go for 100 kilo ohm resistor. What will be the color code? For 100 kilo ohm resistor, it is 1000, again 30 to convert into ohm from kilo ohm. So first band it is brown, for second band it is black, and there is 50, that means 10 to the power 5. So 5 means we know it is yellow. So the color code will be brown, black and yellow for the 100 kilo ohm resistor. So this is 100 kilo ohm resistor, you can see brown, black and yellow. Okay, next go for the capacitor. We know it is non-polarized capacitor, it is value 0.01 microfarad, but in market or in shop, if you go, then you have to tell we want 103 capacitor. How it is 103? That means 10 into 10 to the power 3, 10 to the power 4, it is picofarad. If we want to go to microfarad, we have to divide by 10 to the power 6. That means 1 by 100 microfarad, it is 0.01 microfarad. So from 103 we get 0.01 microfarad. So this is the capacitor 0.01 or 103 microfarad. You can see it, the number. Now we go to the kit. Okay, this is the circuit diagram we designed already. This is 741 IC, you can see it. 741 IC. Keep the rough sheet in front of you. This is the notch. At the pin number 2, one resistor is connected. You can see one resistor is connected. The another point of resistor is connected to the capacitor. You can see it, this one. Two capacitors are connected at the point, and another resistor, that is R2, is grounded. This is ground point. This is ground point. Next, C2 and C3 is connected to the another point, and there is also another resistor, that is R3, which is connected to the ground. The C3 is connected to the output, you can see it, this one. And this is feedback resistor, that is 100 kilo ohm, which is shorted pin number 2 and pin number 6. So this is the circuit. Now we go for the voltage connection to the opamp. Okay. You can see this is plus 12 volt, this is minus 12 volt, and this is ground. So the plus 12 volt, this red probe, we have to connect to the pin number 7. This pin number 7, we connect the plus 12 volt, then minus 12 volt, this one, connected to pin number 4, This is ground connection going to pin number 3. As we short the pin number 3 over here, pin number 3 is short to this common point, we can connect pin number 3 or in this point. So the circuit is completed. Now we switch on the power. Okay, this is CRO. This intention of this focus, you can adjust two channel, channel 1 and channel 2. We have to connect any channel. This is voltage knob. This is time knob for both channel. Now we connect the signal. We connect to show the signal. This is BNC probe. We have to connect the BNC probe. This wire for output. First we have to connect the ground. This is the wire from the kit for ground connection. We connect the ground of BNC probe. Now this is for output. We connect output here. Now you can see the signal in the CRO. So from CRO we have to measure the output. So from this equation, if we put the value, this is 0.1, just I adjust. Oh, it is point. You can resize the signal by this time knob. So we get 3.6 into 50 microsecond. That is the same value, 0.18 ms. So if you calculate 1 by t, that is 1 by 0.18 ms, you would get the value of the frequency. So the value of the frequency will be 5.55 kilohertz. That is the equal to the theoretical value. So it success the practical. Thank you.